Alright, so this is lesson 3.6. Our objectives for today is the student will be able to graph quadratic inequalities in two variables and then also solve quadratic inequalities in one variable. And we're going to do this by both graphing and by doing it algebraically. So first of all, to graph a quadratic inequality in two variables, our first step is to graph the equation y equals ax squared plus bx plus c. And we want to make sure that we use a dashed line if the equation is less than or greater than, but we want to use a solid line if it's less than or equal to or greater than or equal to. So remember, an inequality is it's got a less than, greater than, or less than or equal to or greater than or equal to sign. So we're just going to go through some examples. The first one we'll do is y is less than negative x squared minus 2x minus 1. So we graph this how we've done before. We find the vertex. And so we can find the vertex, remember that's negative b over 2a. And so in this case, b is negative 2, so this would become 2 divided by 2 times the negative 1 is negative 2. And so that is a negative 1. So our x value of a vertex is negative 1. And then we plug that in. So negative 1 squared is 1, and then the opposite of that would be negative 1. And negative 2 times negative 1 is a positive 2 minus 1. So we have negative 1 plus 2 would be 1, minus 1 would be 0. And so our vertex is at negative 1, 0. From here, we just need to plug in values to get enough to know what the graph looks like. And again, our graphs don't have to be perfect on this. So you can plug in the numbers. 0 is an easy one because if we plug in 0, it's just whatever c is, so that's negative 1. And then remember it's symmetrical, so that's negative 1. And then we plug in 1. 1 squared would be 1, and then minus 1, or the opposite of that would be negative 1. And then negative 2 times 1 would be a negative 2. And so we get negative 2, or negative 1 minus 2 is a negative 3, minus 1 is a negative 4. And so then negative 3 also has to be negative 4. So we really only have to find 3 values because it being symmetrical, we can find the other 2. Now there is a shortcut to do this. If we understand it, it makes it a lot faster. And that is if you go to our parent function, y equals x squared. So remember when we plug in 0, we get out 0. And when we plug in 1, we get out 1. When we plug in 2, we get out 4. And so this is, again, symmetrical, so that's 1 and 4. Your new chart for any quadratic, all you have to do is take the value of a, in this case a is negative 1, and you multiply it times the values 1 and 4. So negative 1 times 1 is a negative 1, so I would go down 1 from the vertex, so that's negative 1. And then negative 1 times 4 is negative 4, so I would go down, so here I went down 1, and here I go down 4, and it's just a quick way to make the chart. So I'll show that as we go through, and you can decide which way you would rather do it. The other thing is you can type it into a graphing calculator and get a table and get it that way. They all take about the same amount of time. So when we go to graph this, Alright, so when we graph this, at negative 1, we're at 0. At 0, we're at negative 1. At 1, we're at negative 4. And so here, it's symmetrical again. Now we look at this, and because it's less than, that would be a dotted line, or dashed line. And then what you have to do is, the book says, I put just test a point. So test a point. If the point makes the inequality true, shade that area. If the point makes the inequality false, shade the other area. Now the book will tell you to pick a number inside this. And then if that number inside it works, shade there. And if it doesn't, shade outside. And that's fine to do. But I just find it's easier most of the time to pick the value 0, 0. And so if I pick the value 0, 0, and I plug it into the expression, well, this would be 0 is less than, well, that'd be 0, 0, and negative 1. And you just ask yourself, is 0 less than negative 1? If it is, then I would shade where 0, 0 is. But it's not true, so I don't want to shade where the 0, 0 is. I want to shade opposite that, so inside. Since the 0, 0 was outside and it doesn't work, I shade inside. If the 0, 0 worked, then I would shade on the outside. And so now we're done. Our answer is the shaded area inside of the dotted parabola. So let's take a look at another one. Go ahead and leave that graph there. All right, let's take another problem. All right, so the second problem. Y is greater than or equal to x squared plus 2x minus 8. So again, we do the same thing. We find the vertex. So that would be negative 2 over 2 times 1 is 2. So again, our vertex is going to start at negative 1. We plug that in. So negative 1 squared is 1. Negative 1 times 2 is a negative 2. Minus 8, so that would be negative 9. So again, we're going to make our chart. So now I'll show you that shortcut. If we take our a value, a is 1. Remember, our parent function, our values are 1 and 4 after the vertex. So we just take that 1. Well, 1 times 1 is 1, so that would mean I would go up 1. And 1 times 4 is 4, so I'd go up 4 from the negative 9, and that would be negative 5. And so then, so you can see how quickly I can make the chart out that way. Again, you don't have to. It's really fast here because if I plug in 0, I get negative 8. So that means that's negative 8. And if I plug in 1, 1 squared is 1, plus 2 is 3, minus 8 is a negative 5. So it saves a little bit of time if you can understand it, but it's not hard to make the chart. So now we graph this. So at negative 1, we're down at negative 9. So I'll have to extend this a little. So at negative 1, we're at negative 9. At 0, we're at negative 8. At negative 2, we're at negative 8. And at 1, we're at negative 5. And at negative 3, we're at negative 5. And because this is greater than or equal to, this is going to be a solid line. And again, this doesn't have to be perfect. It's obvious that 0, 0 is inside that. So I'm just going to try 0, 0 again. I'm going to test this point. So I plug in 0, 0. Well, y would be 0 is greater than or equal to negative 8. And it is greater than or equal to negative 8. So I want to shade inside of the parabola. Okay, so however far this goes, that green area is going to be shaded all the way in there. So let's take one more. Y is greater than negative x squared plus 2x plus 4. So we find the vertex. That would be negative 2 divided by negative 2, so that would be 1. When I plug in 1, 1 squared is 1, so that's negative 1, plus 2 plus 4, so that would be 5. Again, I just need to go 2 above it and 2 below it. Again, let's use the shortcut. Negative 1, we multiply that by 1 and 4, so negative 1 times 1 is a negative 1, I go down 1. Negative 1 times 4 is a negative 4. Again, from 5, I go down 4, so that would be 1. And so this would be 4 and 1. Again, a quick check. When I plug in 0, I get out 4. And so it's just a quick way to do that. So again, you can plug in the numbers. You only need to plug in 2 more anyway because it's symmetrical. So we make the graph. So if I go to graph this, at 1 we're at 5, at 0 we're at 4, 2 we're at 4, at 3 we're at 1, and at negative 1 we're at 1. This is a greater than, so it's just a dotted line. Again, it's easy to see that 0, 0 is inside this. If 0, 0 is close, you can pick any number you want. It doesn't make any difference. You can check negative 5, 0 or 5, 0. You can pick any numbers you want. It's just that 0, 0 is quick. So we take 0, 0, we check it. 0 is greater than, that all becomes 0, so 4. 0 is not greater than 4, so since it's inside and it doesn't work, we shade outside. And that would be our graph. All right, so it's real quick to find the points and then find the solution area. All right, next let's solve a system of inequalities. So we follow the same steps we do for one inequality, and then we just do it twice and we find the overlap. So as an example, if I had y is less than negative x squared plus 3, and y is greater than or equal to x squared plus 2x minus 3. And we wanted to find the solution of both that system of inequalities. So let's do the graph. All right, so if I take the first one, we'll do that in red. So our b would be 0, and 0 divided by negative 2 would be 0. So my vertex would be 0, plug it in, 0 would give me 3, 1, 2, negative 1, negative 2. Again, the shortcut would be, we go to our parent function 1, 4, negative 1 times 1 would be negative 1, so it goes down 1. Negative 1 times 4 would be negative 4, so we go down 4 from negative 3, that would be negative 1. Again, we could just plug in those numbers to get it, but that's a quick way to do it. So we graph that. At 0, we're at 3. At 1, we're at 2. Negative 1, we're at 2. At 2, we're at negative 1. And at negative 2, we're at negative 1. And it's less than, so this would be a dotted line. And again, 0, 0 is inside that, so I'm just going to check it. 0 is less than 0 plus 3, which is true. So I want to shade inside of that. I'll do the next one in green. So our vertex here, the opposite of 2 is negative 2 divided by 2 would be negative 1. Plug in negative 1, that would be 1, minus 2, minus 3, so that would be a negative 4. Again, using the shortcut, 1 times 1 is 1, so it goes up 1. Again, easy to check, 0 would give me 3. 0 would give me negative 3. 1 times 4 would be 4, so it would go up 4, and so that would be 0. And so negative 2 would be negative 3, and negative 3 would be 0. And so this one at negative 1, we're at negative 4. So approximately there. At 0, we're at negative 3. At 1, we're at 0. At negative 1, negative 2, we're at negative 3. And at negative 3, we're at 0. This one is greater than or equal to, so that is a solid line. And now we check this one. Again, I'm going to check 0, 0 because it's inside. 0 is greater than, this would be 0. 0 is greater than or equal to negative 3. That's true. So I want to shade inside. And so my answer is the overlap. So it would be this dotted line to there. This would be a solid line to there. And then the overlap is what I shade. And so that's how you do it if it is a system of equations. You just do each one separately, and then it's the overlap of the two regions. Lastly, we're going to look at solving algebraically. So to solve a quadratic inequalities algebraically. So let's take x squared minus 3x minus 4 is less than 0. So we want to set the equation equal to 0 or an inequality, whatever it happens to be. So it's set equal to 0, we've got that done. Then we solve for x. And so this we can either factor. If it's just an x squared, we can take the square root of both sides. We can use the quadratic formula. Totally up to you which you use. Again, I always try and factor if possible. So this would be negative 4 and negative 3. And so that would be negative 4 and 1. And so it factors into x minus 4 and x plus 1. So that, remember, to solve this, set them equal to 0 and solve, where the shortcut is the opposite of this, divided by the number in front. So my values for x are 4, and then the opposite of this would be negative 1. So those are my answers. And so then we test it on the number line. So here's what you do on this. You draw the number line. And again, all I care about is, you don't need to put any other numbers on there. Just get the numbers negative 1 and 4, your answers. And then you test the areas that it got split up to, and you find out which ones work. So let's try negative 2. So we plug negative 2 in. Negative 2 squared is 4. Negative 3 times negative 2 would be positive 6. Minus 4 is 6. And 6 is not less than 0. So this would be, that area doesn't work. So now we just pick a number between negative 1 and 4. I'm going to do 0 because it's quick. 0, 0, negative 4. So I get negative 4 is less than 0. That does work. So that's yes. And then I try a number bigger than 4. Let's say 5. 5 squared would be 25. 3 times 5 is 15. 25 minus 15 is 10. 10 minus 4 is 6. So again, we get 6 is less than 0, which is not true. So that's no. And so that means the only area that works is between negative 1 and 4. So all you do is you put x, and then you put it x is less than, x is greater than. According to this sign, if this had a less than or equal to or greater than or equal to sign, then you would put the less than or equal to, greater than or equal to. But now you just put the numbers. It's greater than negative 1 and it's less than 4. And so that's how we write that answer. So another example. Let's take 3x squared minus x minus 5 is greater than or equal to 0. So again, it's already equal to 0. We solve for x, negative 15 and negative 1. And there are no numbers that subtract to give you, multiply together to give you negative 15 and subtract to give you negative 1. So we're going to have to use the quadratic formula. So we're going to go negative 1, negative b, so that would be positive 1, plus or minus the square root of 1 minus 4 times 3 times negative 5, all over 2 times 3, so 6. So if we multiply this, we get 4 times 3 is 12, times 5 is 60. We have 2 negatives, so that's a positive. So we get 1 plus or minus the square root of 60 all over 6. So we found our answer for x, and so what you do is this. Still, we take our number line. This is 1 plus the square root of 60. Actually, this would be 1 minus the square root of 60. Divided by 6. And 1 plus the square root of 60 divided by 6. And so we don't have to be exact on this. We just have to pick numbers that are in these areas. So this is going to be a negative number. Now, negative square root of 60 is about 7 point something. So it would be 1 minus 7 point something. This is going to be a little bit bigger, or a little bit smaller than negative 1.1. but it's not going to be negative 2. So we need the ballpark, because now we can just check negative 2. So I'm going to plug in negative 2 and see if it works. So when I plug in negative 2, I get negative 2 squared is 4, so that would be 12. Negative 2, that would be plus 2. And 12 plus 2 is 14 minus 5 is 9, and 9 is greater than or equal to 0. So this does work. This is a yes. Now again, this over here is going to be 1 plus, 7 is going to be 8 something. Again, it's going to be 1.3. Doesn't make any difference. But I know 0 is between the negative and the positive, so I'm going to try 0. Well, 0, 0, negative 5 is not greater than or equal to 0, so this is a no. And then we check the number outside, so again, let's just take 2, something bigger than 1.3. So 2 squared is 4, times 3 is 12, minus 2 is 10, minus 5 is 5, and that is greater than or equal to 0. So that's a yes. And so now we have the numbers outside of this. So now we know that x is less than or equal to, because of the sign, less than or equal to 1 minus the square root of 60 over 6. We could simplify that. Let's do that. This becomes 4 times 15. So that's 1 plus or minus 2 square root of 15 over 6. So I'm going to go ahead and change that. So 1 minus 2 square root of 15 over 6. Or, because it can't be and, because it can't be both less than and greater than. So or x is greater than or equal to 1 plus 2 square root of 15 over 6. And so when it's opposite, you just put an or between the two. So let's take one where it's not equal to 0. Let's take 2x squared plus 3x is less than 2. So the first thing is we set it equal to 0. 2x squared plus 3x minus 2 is less than 0. Try and factor that. We get negative 4 and 3. So that would be 4 and negative 1. Now we have to build the box because a is not 1. So that's 2x squared minus 2 and 4x and negative x. Greatest common factor is 2x. Greatest common factor would be 1. It's minus for the first box. X and 2. And the first box is positive. So it's 2x minus 1 and x plus 2. And so we get 1/2. Opposite that divided by that. Opposite 2 is negative 2. So now again we go to the number line. We have negative 2 and 1/2. So again, I'm just going to check a number inside each area and see what works. So let's try negative 3. Plug it in here. Negative 3 squared would be 9 times 2 is 18. Plus negative 3 would be negative 9, and so that would be 9 is less than 2. That's not true. So that would be no. Plug in 0. 0 makes it easy. 0 is less than 2. So that's yes. And then check 1. 1 squared is 1 times 2 is 2. Plus 3 times 1 is 3. 5 is not less than 2. And so that's no. So now again, since it's between negative 2 and 1/2, I just do x is less than, because there's no equal to sign, less than 1/2, and it's greater than negative 2. So let's do one more where it's not over there, just to make sure we're clear on this. So lastly, let's take one more. 2x squared plus 2 is greater than negative 5x. Set it equal to 0. Move the 5x over by adding it. Plus 2 is greater than 0. factor that. 2 times 2 is 4, 5, so it would be 4 plus 1. We have to build the x. 2x squared, 2, 4x, x, 2x, 1, it's plus because the first box is positive, x, 2, plus, so 2x plus 1, and x plus 2, and so we get negative 1/2, negative 2. So now we do our number line, negative 2, negative 1/2. Let's plug in negative 3. Negative 3 squared would be 9. 18 plus 2 is 20. Is greater than negative 5 times negative 3, which would be 15. And 20 is greater than 15, so that would be a yes. Plug in negative 1. Negative 1 squared would be 1 times 2 is 2. Plus 2 is 4. Plug in negative 1 times 5 would be 5. 4 is not greater than 5, so that's no. And then plug in 0. So we get 2 is greater than 0, which is true, so that's yes. So again, it's the outsides. So x is less than negative 2, or x is greater than negative 1/2. So hopefully that's enough examples to square it up for you and make sure you're okay. And so your assignment is page 144, 3 to 37, the odds, which is also going to be on the computer. So good luck with that. Hope that helped.